Hi everyone! Let us now continue our learning activity video for Senior High School, General Mathematics, Quarter 1, Week 2, C. Objective: the learner solves rational equations and inequalities. We have our learning material. Then we have the generalizations. Solving rational equations and inequalities. To solve a rational equation, the following steps may be used. First, determine the least common denominator or LCD of all rational expressions in the equation. Then, multiply each side of the equation by the LCD. Then, solve the resulting equation by applying different properties of equality. Then, check the solution by replacing each variable in the original equation. To solve rational inequality, we have the following steps. Rewrite the inequality as a single rational expression on one side of the inequality symbol and 0 on the other side. Number 2, determine over what intervals the rational expression takes on positive and negative values. And we have the 4 steps here. Locate the x values for which the rational expression is 0 or undefined. These are the critical values. And how to find the critical values? We have factoring in the numerator and the denominator. So this is one of the useful strategy. For letter B, mark the numbers found in step A or in finding the critical values on a real number line. Use a shaded circle to indicate that the values is included in the solution set, and a hollow circle to indicate that that particular value is not included. These numbers partition the number line into intervals. C. Select a test point within the interior of each interval in step B. The sign of the rational expression at this point is also the sign of the rational expression at each interior in the aforementioned interval. D. Summarize the intervals containing the solutions. Take note that multiplying or dividing both sides of an inequality by a number requires that the sign of the number is known. It could be either positive or negative. If the sign of a variable is not known, it is not valid to multiply or divide both sides of an inequality by a variable. Please remember that multiplying an inequality by a negative number will reverse the inequality symbol. For example number 1, solve for x. We have 7x plus 3 all over x squared minus 8x plus 15 plus 3x all over x minus 5 equals negative 1 over x minus 3. This involves rational expression in fractional form. So we have to solve for x. For the solution, step 1, we have to determine the LCD. So what are the denominators first before determining the LCD? So denominators are x minus 5 here, so we have it here, then x minus 3, and this one, x squared minus 8x plus 15. But this can be factored out as quantity x minus 3 times quantity x minus 5. There are 3 denominators that we found here. So we have to select what is the least common denominator, or the LCD. The LCD is the one that when multiplied to this each term of the rational expression or equation will eliminate fractions. So well, the LCD is actually x squared minus 8x plus 15 in factored form. Or we have quantity x minus 3 times quantity x minus 5. For step 2, we have to multiply both sides of the rational equation by the LCD. So we're allowed to do that by the multiplication property of equality. So we have the original term given, then multiplied by its LCD. The next is to distribute this LCD to each of the side of this equation. And let's deal first with the right-hand side of the rational equation. We have it here. So we have negative 1 over x minus 3 times quantity x minus 3 times quantity x minus 5. So we can cancel out the factors x minus 3, and then in the denominator of the right-hand side of the rational equation, we have x minus 3. And this gives us negative x plus 5. Why? Because we have here negative 1 times the quantity x minus 5. So to simplify, we have negative x plus 5. Step 2 on the left-hand side of the rational equation. So this is the left-hand side multiplied by the LCD quantity x minus 3 times quantity x minus 5. Let's consider first the first term of the left-hand side. And we found out that x minus 3 here can be cancelled with this term. The another one cancels out, giving us 7x plus 3. Plus the second term, 3x all over x minus 5 multiplied by the LCD. We can cancel out x minus 5 and x minus 5. So we have to simplify 7x plus 3, then plus 3x times quantity x minus 3 is equal to the right-hand side, which is minus x plus 5. So you can simplify further. We have 7x plus 3, we can take out from parentheses, then plus multiply 3x times x, this becomes positive 3x squared, then 3x times negative 3, we have negative 9x, we copy the right-hand side. Then simplifying this will give us 3x squared minus x minus 2 equals 0. So we copy 3x squared minus x comes from negative 9x plus 7x, that becomes 2x. Then we have plus x. So negative 2x plus x becomes minus x. Then we have negative 2 because positive 3 here, and then from here we transpose negative 5 on the other side. So we have positive 3 minus 5, that becomes negative 2. Leaving the right-hand side 0. This becomes further, we need to factor out. So this becomes 3x squared minus x minus 2 equals 0. Factors are, say we can have 3x on this first factor, and on the other side here we have x. Then what are the factors of negative 2? Such that later when we check this by FOIL method, it will give us negative x. So factors of negative 2 are 1 and negative 2. So let's have this one. So this will become x minus 1, and then this is plus 2. If we check, we end up with this expression, 3x squared minus x minus 2. Let's check. 3x squared, then minus 3x plus 2x, that becomes minus x. Then we have positive 2 times negative 1, that becomes negative 2, then 0. So the factors are 3x plus 2, and the other one is x minus 1. Then we set each of these factors to 0. The first factor, 3x plus 2 equals 0, will give us x equals negative 2/3. And the second factor, x minus 1 equals 0, will give us x equals 1. So we have two values for x that will satisfy this rational equation. One is x equals negative 2/3, and the other one is x equals 1. For step 4, we have to check and verify. So we go back to the original rational equation given. For x equals 1, we just simply substitute the value of 1 for all the x's here in the original expression. So we have it here. In this case, we need to put the question mark here because we are not sure whether the left-hand side expression is really equal to the right side of the equation. The left-hand side will become 10 over 8 plus 3 all over negative 4. Then this is equal to 1 over 2. The negative will be cancelled out. Still, we have the question mark. We're not sure. Then further, we have 5/4 minus 3/4 or equals 1/2. Then we have a check. So in this case, we found out and we are very confident that x equals 1 is the solution for this rational equation. For x equals negative 2/3, we have to substitute x equals this value for the original rational equation. Let's do that. 7 times x, or 7 times negative 2/3 plus 3 all over negative 2/3, square that, minus 8 times negative 2/3 plus 15, plus 3 times negative 2/3 all over negative 2/3 minus 5. Is this equal to negative 1 over negative 2/3 minus 3? Moving on. In this case, we can cancel out the 3. Okay, so this will be simplified as negative 2, but still we need to verify further. So this becomes now negative 14 over 3, because we have 7 times negative 2 all over 3, plus 3, just copy. Then we have the square of negative 2/3, that's 4/9. Then we simplify negative 8 times negative 2/3, that is 16 over 3 or 16/3. We copy 15. Then we copy the plus sign. We have a simplified negative 2. Then to simplify this becomes the negative 5 in terms of 1/3. How many 1/3 in negative 5? So there are 15 over 3 minus 2. That becomes negative 17/3. This is equal to, or is this equal to? There's a question mark. Then the negative here and the negative, we factor the negative here and then we cancel out with the negative. So this becomes now 11 over 3. Why 11 over 3? Because we have 3 plus 2/3. That's 11/3. Then we simplify further. Negative 14/3 plus 3. There's a negative here and a positive, so we have 2 minus. The 3 is equal to 9/3. So we have negative 14 plus 9/3. That becomes negative 5/3. Simplifying 4/9 plus 16/3 plus 15 will give us 187/9. Then simplifying this will give us positive 6 over 17. And this is equal to 3 over 11. But we still have to put a question mark because we are not yet sure. And the final step is, this is negative 5 times quantity 3 over 187 plus 6 over 17. We just copy. And 3 over 11. Is this equal to 3 over 11? Well, we have this to check. You can solve it in your calculator and it's correct. Hence, the solutions to the given rational equation are x equals negative 2/3 and x equals 1. Example 2. Solve the rational inequality 1600 over x plus 4 is greater than or equal to 1120 over x plus 10. Again, so we have to put on the one side of the inequality all the terms, leaving the other side 0. So we have it here. This becomes now 1600 over x plus 4 minus 1120 over x minus 10 is greater than or equal to 0. Starting from this, we have now to multiply this by x over x. Why? Because we have x plus 4 as the denominator and another denominator x. And we have the whole number 10, its denominator is 1. So among x plus 4, x and 1, we have to have a single inequality or a single fraction that has all these denominators, x plus 4 times x times 1, or simply quantity x plus 4 times x. So in the first term of the left-hand side, we need x. So we have 1,600 over x plus 4 times x over x. This is actually equal to 1, so multiplying that to this term here will not affect the inequality, but will change. This inequality will be transformed in such a way that we have 1600x over x plus 4 times x. So in the denominator, we have x plus 4 and x. The same is true with the second term. They have the same denominator as the first term. And so with the third term. So let us try to simplify further here. So we can combine these terms in the numerator, giving us a single expression in the denominator, which is x times quantity x plus 4. So simplifying, we have 1600x minus 1120 times quantity x plus 4 minus 10x times quantity x plus 4 is greater than or equal to 0. Simplifying further, we have this expression minus this one minus the negative 1120 times 4. This gives us negative 4,480. Then we have 10x squared, then minus 40x. All over the denominator, greater than or equal to 0. Let's proceed further. So we have here, let's try to write it down. So we have negative 10x squared. Then we have plus 440x. Why do we have that? We have this orange circled one. We combined like terms. So this becomes 440x. Then we copy the constant, negative 4,480. And we copy the denominator. Then this will give us the red colored circle that indicates that this expression comes from the red circle here. So combining like terms, again we have to factor out. Common here is 10. So take away or factor out negative 10. This will give us x squared minus 44x plus 448 all over x times quantity x plus 4 greater than or equal to 0. Then we have negative 1 over 10 multiplied to each side of the inequality. Why do we need to do that? Because we need to eliminate the negative 10 in this expression. So multiplying by a negative number will change the sign of the inequality. So take note, this is greater than or equal to. This becomes less than or equal to because we multiplied or we divide by a negative 10. So we multiply by negative 1 over 10, or that is equivalent to saying we divide by negative 10. But since it is a negative number, it's the multiplication property of inequality that will justify this process, that this inequality will be reversed. Let's try to simplify. Simplifying will give us x squared minus 44x plus 448 all over quantity x plus 4 times x less than or equal to 0. Factoring out, we have quantity x minus 16 times quantity x minus 28 all over the denominator less than or equal to 0. Then, we have here a real number line. So, let's discuss letter B. The rational inequality is 0 for x equals 16 and x equals 28. And it is undefined for x equals 0 and x equals negative 4. So, 16, 28, 0, and negative 4 are what we call the critical numbers. So we need to plot these critical numbers arranged in descending order in a real number line. So we have here a real number line. Then let's say this is not drawn to scale. Let's just say this is 0 here. And of course, to the left of 0 is -4. Then to its right is 16. And 16 comes before 28. This is one way of plotting the critical numbers so that we can see that in this case, -4 is not included. We have a hollow circle because it will make our inequality undefined. The same is true with x equals 0. But in the case of 16 and 28, it is a filled circle, meaning 28 and 16 will make the inequality 0, and it's allowed in our rational inequality given. Let's proceed to letter C, the sign analysis table. So we have here the original expression, and keeping in mind those critical points that we have earlier, let's recall them. So let's say this is the line here for our real number line. So we have -4, this one, then 0, then 16, and 28. I presented here the sign analysis table. Let me discuss this one by one. Remember in the previous slides, we have a hollow circle here, and above that is -4. So let's keep that in mind, that -4 is not included as a solution set of our inequality. Like in this case here, if this is -4, the whole inequality will be undefined. So it's a no, meaning we cannot include -4. The same is true with x equals 0. We cannot include x equals 0. So let's start with the interval, or to the left of x equals -4, we have the interval -infinity to -4. We have an open interval. Okay? So here, between -4 and 0, we have an open interval, -4 to 0. And 0 to 16, we have here a closed half open interval. We can read this as half open interval 0 to 16. In this case, we have a bracket after 16. That means that x equals 16 is included in our solution set, if this is to be our solution set. Let's try to see later. Now, in this case, 16 and 28, this interval indicates that 16 can be included and also 28 can be included. So we have two brackets, the open and the closed bracket. Then after 28, we have 28 to positive infinity. We put again an open bracket here because this indicates that x equals 28 can be included in our solution set, if this particular interval here will be our solution set. Then we have to assign test points. In this case, x equals -5, meaning we have to assign numbers between this interval. So, -5 is within this interval, so we can take -5. Between open interval -4 to 0, we have x equals -1. Between 0 to 16, we can pick x equals 1. Between 16 to 28 inclusive, we have x equals 17. And between 28 to positive infinity, we can choose 30 or 29. Now, let's collect all the terms in our inequality here. X minus 16, let's put it here. Then we have x minus 28, the second factor of the numerator. Then we have the first factor of the denominator x. We copy this here. Then the second factor of the denominator x plus 4, we have it here. And then, how did we get the negative sign here? Well, replace this x by our test point in this particular interval. So in this case, x is -5 minus 16. We're not concerned about the value, but the sign. So -5 minus 16, that is a negative number. It's actually -21. So it's a negative number. Then we have -5 minus 28. It's still a negative number. Then we have -5, negative. Then we have -5 plus 4. It's a -1. It's negative. We let I be x minus 16 times x minus 28 all over x times x plus 4. To simplify, we have to write I here. I is positive here. Why positive? Because negative times negative will become positive all over negative, that's negative, but negative times negative, positive. Or we can count the number of negatives. There are 4. If the number of negatives is even, then we have a positive sign, because the rule of negative and positive numbers in multiplying and dividing are just the same. Now, let's consider between this interval -4 to 0, an open interval. So our test point is -1. So -1 minus 16, still negative. -1 minus 28, that's negative. -1 is negative. Then -1 plus 4, that becomes positive, because -1 plus 4 is positive 3. Okay. Now there are 3 negatives and 1 positive. Then we have a negative in the final inequality. So for x equals 1, positive 1, 1 minus 16, negative, 1 minus 28, still negative, 1, positive, 1 plus 4, it's 5, positive. So 2 negatives, 2 positives, the result is positive. For x equals 17, 17 minus 16, that's positive. Then 17 minus 28, negative. Then 17, positive. Okay. How about this one? 17 plus 4? What's your guess? It's positive. You can see it. And you're correct. Then we have positive times negative. It's negative over the positive. That is negative. And x equals 29. We have 29 minus 16, positive. Then 29 minus 28, positive. Of course, positive, 29. 29 plus 4, 33, positive. Then we have positive. So let's go back to the original inequality. Actually, this inequality should be less than or equal to 0. When it is less than or equal to 0, the less than here indicates that a negative sign. So we have to take all the negative intervals here, and that is our solution to this particular rational inequality. Then take note, we have equal to 0 all those x values or critical values that will make our inequality 0 are 16 and 28. So let's recall. We have the solutions set here. So we can take this one because this is the only interval, these 2 intervals here, that will make our inequality true. So it says here -4 less than x, x is less than 0 for this part of the interval. Union, we use the union of sets. We have 16, we include 16 less than or equal to x, and x is less than or equal to 28. Or we can rewrite this in the interval notation. We copy this interval -4, 0, union that with an open and closed bracket. This is a closed interval 16 to 28. This ends quarter 1, week 2C, and see you in the next learning activity videos. If you are not yet a subscriber of my channel, kindly subscribe, and please don't forget to like and share. And if you are a subscriber, you will be updated with more uploads for these learning activity videos. Thank you, and always stay happy, healthy, and safe.